We are waiting for all the dignitaries to join. Kindly bear with us. नमस्कार, मैं समर्पिता सरकार अंतरिक्ष उपयोग केंद्र से आप सभी का हार्दिक स्वागत करती हूँ।
I, Arpita Gajaria from Space Application Center, ISRO Ahmedabad.
Okay, fine.
Heartily welcome you all to the Silver Jubilee celebration of IRS-1C launch organized by Indian Society of Remote Sensing in association with Space Application Center, ISRO Ahmedabad. We are honored to have with us today our chief guest, Dr. Kasturi Rangan, former chairman ISRO and former secretary, Department of Space, and our guest of honor, Dr. K. Shivan, chairman ISRO and secretary, Department of Space. Sirs, kindly accept our heartfelt thanks for accepting our invitation to grace this occasion. We are privileged to have with us today stalwarts who have laid a strong foundation for India's space program, Dr. George Joseph, Sri A.S. Kiran Kumar, Dr. P.S. Goel, Dr. R.R. Navalgund, Dr. Shailesh Nayak, Dr. Kalyan Raman, Dr. Ram Ratan, Director NRSC, Sri Shantanu Chaudhary, Director SAC, Sri D.K. Das sir, and Associate Director SAC, Sri Nilesh Desai sir. We welcome you all. Sir, we are humbled by presence of you all. We extend our gratitude to all the respected dignitaries, ISRS members, and colleagues across the different ISRO centers for joining with us today.
IRS-1C was India's second-generation remote sensing satellite. The payloads on board IRS-1C had the unprecedented higher spatial resolution panchromatic camera with less than 6-meter resolution, multispectral LIS-3 camera with 23.6-meter resolution, 189-meter large swath WIFS camera, altogether with a high repeativity of 5 days. The reverberation of this successful launch led to a paradigm shift in the remote sensing applications for civilian usage. We take the opportunity of this celebration to express our respect and gratitude to the stalwarts who revolutionized remote sensing in India and initiated the geometric domino of using space technology for the benefit of the society.
The year 2020 also had a paradigm shift in the way we perceive and execute things. Virtual world has been embraced globally during the pandemic times, and so have we. Light is a symbol of auspiciousness and abundance. We pray to the Almighty to guide us on the righteous path of knowledge and wisdom. दीपक का प्रकाश सभी के जीवन को मंगलमय बनाए, ऐसी कामना के साथ we'll now have virtual lighting of the ceremonial lamp. May we have the slide, please?
शुभं करोति कल्याणम् आरोग्यं धन संपदा शत्रुबुद्धिविनाशाय दीपज्योति नमोस्तुते दीपज्योति नमोस्तुते
technology has become a part of civilians' day-to-day lives. Over the past few decades, not only the sky and moon has come closer to home, but the perception frame has changed as well. Let's experience the cognitive shift in awareness as described by the astronauts to be the overview effect with this short movie conceived and prepared by the Development and Educational Communication Unit DECU team with the assistance of ISRS and SAC team titled Bird's Eye in Space, celebrating Silver Jubilee of IRS-1C. Can we have the movie, please?
Let us travel back in time. Kerala, 1970. Kerala, one of the southern states of India, has always been famous for its coconut production. Way back in 1970, a serious problem hit the coconut crops. It was the dreaded root wool disease, which affected the yield very badly. In those days, the only solution to the problem was for a person to climb each tree and inspect it for the disease. Obviously, this was extremely challenging and time-consuming. It was during this troubled time that Professor P.R. Pashorati, an ISRO scientist, came up with an ingenious solution of detecting this disease from a helicopter using color infrared aerial photography. Even so, due to the small field of vision from the aircraft, this practice could not be sustained for long. A long-term and viable solution was needed. This gave birth to an idea of carrying out photography and sensing the Earth from an orbiting satellite. The Indian Remote Sensing Program made a beginning in 1988 with the launch of IRS-1A, which was followed by a series of satellites, IRS-1B, 1C, and many more. The primary objective of IRS satellites was to provide systematic and repetitive observation and acquisition of remotely sensed data of the Earth's surface under nearly constant conditions of illumination. The Indian Remote Sensing IRS system has today emerged as one of the most high-profile programs in the international commercial satellite imaging industry. Its primary focus is to develop space technologies and its diverse applications to support national development in various ways. If we look at the history of IRS systems, IRS-1A and IRS-1B carried LIS-1 and LIS-2 sensors with spatial resolution of 72.5 meter and 36.25 meter respectively. LIS-1 had a swath of 148 kilometer and the two LIS-2 cameras had a composite swath of 145 kilometers. Launched on 20th December 1995 by a Molniya M rocket of Russia from the Baikonur Cosmodrome, IRS-1C was India's second-generation Earth observation satellite. It was equipped with a 5.8 meter panchromatic camera and a 4-band multispectral LIS-3 camera with shortwave infrared band capability. Due to its ability to provide high-resolution data and some frequent coverage from a unique combination of sensors, it was considered as one of the most advanced satellites of the time, which provided such spatial resolution in civilian domain. The spacecraft was used for land and water resource management, applications in forestry, agriculture, environment, soil characteristics, wetlands identification, flood and drought monitoring, ocean resource development, mineral exploration, land use and monitoring of underground and surface water resources. In the year following the launch of this satellite, its effect was seen in the more accurate forecast of the wheat production in the country. The satellite also helped in measuring crop acreages, agroclimatic planning and production forecasting. IRS-1C was followed by many other series of satellites, such as OceanSat, RISat, SCATSat, CartoSat, ResourceSat, INSAT, etc. All of these put together became the workhorses of the Indian remote sensing program. Some of these were focused on observation of landmass, some on oceans and weather, some were dedicated to land and water resources, and yet others were designed for cartography. Each of these satellites had a few things in common. They provided high resolution, stereoscopic views and data and had extensive coverage, hitherto rarely seen before. Over the years, ISRO has perfected the art of developing various types of sensors in visible, near-infrared, shortwave infrared, thermal infrared, and microwave regions. OceanSat in 1999 made the beginning for monitoring oceans, and SCATSat in 2016 enabled us to study wind vectors. The CartoSat series, beginning in 2005, enabled high-resolution imaging for cartography and its related applications. The launch of RISat in 2012 heralded the era of Earth observation through microwave radar imaging, which can see through the clouds. Hyperspectral imaging ushered and put the country in a still higher pedestal with the launch of HISIS in 2018. ISRO also launched meteorological geostationary satellite Kalpana-1 in 2002, which was later followed by the INSAT 3D and 3DR. India today is the proud custodian of the world's largest constellation of remote sensing satellites. This system offers space-based Earth observation data in a variety of spectral bands, spatial resolution, and SWATs. Remote sensing data is used by a number of different agencies, including the IMD and state remote sensing institutions, for analysis and prediction. Most notably, the GeoMG project successfully used remote sensing data for online recording and monitoring of assets and effectively mapped terrain for future development. Real-time flood monitoring and early warning is another practical area where ISRO uses remote sensing data to forecast and warn people about imminent danger. Today, the agency, which uses IRS services for their activities, the data from IRS has become an indispensable tool. Planted by the father of the Indian space program, Dr. Vikram Sarabhai, Dr. Pashorati, and many other luminaries, the Indian remote sensing program has now grown into a huge banyan tree, and its impact is today being felt in all walks of life. ISRO continues to be committed towards serving the needs of the common man for sustainable national development.
A heartfelt thanks to ISRS, SAC, and DECO team for creating this mesmerizing video. It gives a real sense of connection to something much bigger than our individual being, similar to the sense of unity and belonging in this harmonious and versatile organization. Yes, indeed. As it is rightly said, no one can whistle a symphony. It takes a whole orchestra to play it. And just like an orchestra, this celebration has been meticulously guided and designed by our distinguished scientist, Associate Director SAC, and President ISRS, Shri Nilesh Desai sir. We feel privileged to have sir with us today. Shri N.M. Desai sir had made illustrious contributions towards design and development of ISRO's microwave radar payloads. He has guided activities for the development and realization of advanced and synergistic applications involving Earth observation, SATCOM, SatNav applications for societal benefits and strategic uses. We would now request Sri Nilesh Desai sir to kindly deliver his welcome address and give an overview of today's program. Sir, please.
Good afternoon, everybody, all the participants as well as dignitaries on the dais. At the outset, let me welcome all of you And for especially we are very happy on behalf of ISRS that all of you have readily agreed to join this program and enlighten us with the eventful journey of IRS-1 program as well as the subsequent events. At the outset, let me welcome all of you and inform you that IRS-1C has been a great milestone in the history of Indian space program. It is being called that it is both 1, 2, 3, 4 of the Indian optical remote sensing program. One, in the sense that it was the first satellite. Second, because it was our first second generation satellite. Third, because it was ABC, IRS-1C, third in the operational series. And fourth, because it was our fourth operational satellite in Indian optical remote sensing history. So in that sense, it has its great importance. One more reason for that was also because at that time in 1998, 28 December, when it was launched and made operational, it gave panchromatic images of the resolution of 5.84 meters. So that were, on those days, one of the best resolution camera images available from any of the spaceborne systems. And for that credit goes to all the luminaries who are present here today on this particular event. So I once again congratulate on behalf of ISRS and all of us for making this happen. And in fact, that was the first time when today we are talking about opening up of the space sector for private players. That time, this first time our data was used being the highest resolution data, it was better than Landsat as well as Spot 4, who were giving images up to resolution of up to 10 meters. And 5.84 meters was one of the best available those days. And it was, in fact, 19 to 20 ground stations were able to receive this data, and it was marketed during those days. So 25 years before, we have started this whole particular activity related to using our data commercially for national as well as international users. So in that sense, it was a milestone achievement. I welcome you, sir, all of you, for this very important event. And I'm reminded of, we are trying to celebrate this completion of launch 25 years after it was launched. In fact, some misguide it as a operational 25 years. It was, the satellite lasted for almost 9 years. In 2007 September, it was inoperational. So in that sense, we are celebrating only the up to 25 years when it was launched first. And since it was a very great satellite in our series, we want to celebrate this particular event. And especially with the presence of all of you, I am reminded of Tare Zameen Par. We are trying to celebrate a satellite in orbit. And here we have many pseudo satellites, as we call in our navigation parlance, stars on the earth. They are all there, and they will illuminate us with the various events which went through this particular saga which we have celebrated. So coming to all of them, Dr. Rangan sir, he is the Bhisma Pitama of our space program, and he needs no introduction. वो सूरज को दिया बताने समान होगा. He is the architect of our new education policy 2020. All of you are well aware of that. And he is the pioneer of our IRS-1 program. And in that sense, we'll like to hear from him about this whole IRS saga. This will be followed by Dr. K. Shivan sir's roadmap for Indian and ISRO space program related to remote sensing scenario, especially when we are now trying to open up the sector for various other players as well. So his lecture will give us the insight into how India's remote sensing program is going to shape up. This is a very unenvious task in a sense, because he has to protect ISRO's interests, at the same time open up the space sector so that more players indulge into this particular activity, and the space activity, aerospace and other related activities get impetus in the country as per the wish of government of India. This is followed by Dr. George Joseph. He needs no introduction. Dr. George Joseph has been the pioneer. He is the father of our optical remote sensing payload program here at Space Application Center. And we are fortunate that he's here with us, physically present here, along with all of us here in Vikram Hall. And especially I'm thankful to Dr. George sir, not only for his yeoman contribution to the Indian space program that is well known and it needs no introduction, but because he first gave me this idea that why not we organize this particular event at the completion of the launch of 25 years of IRS-1C. And I immediately lapped up that idea. And there were two major reasons. They were secret at those times. I will now like to reveal that. One is 20th December is the birthday of my wife. So in that sense, I was very happy that it is being celebrated today. So at least I could tell her that. Secondly, because we have presence of two of our major stars here. One, Sri Deepak Das sir, he is Director SEC, as well as Dr. Santanu Chaudhary ji, Director NRSC. Both the centers have been leaders as far as remote sensing activities, whether payload development and its applications are concerned. And both of them have contributed. They've come up from a very humble background and rise to the directorship of the various centers of this ISRO organization. And we are happy to felicitate him. So I thought that it will be a very good idea in presence of all these luminaries. We have this felicitation program for both these center directors. So we thank Dr. George sir for giving us this wonderful idea of celebrating this particular thing. And ISRS is in the sense our society is grateful to you, sir. Now this Dr. George's talk will be followed by Dr. Kiran Kumar sir. He needs again no introduction. And for 40 years, sir has been the mainstay of our payload programs, whether it is optical or microwave. In fact, when we started our microwave remote sensing program, we were in a rival camp, as it is called those days. So we were thinking that micro remote sensing and optical remote sensing were working at cross purposes. But afterwards, we found that Dr. George, Dr. Kiran Kumar sir and Dr. Naval Gun sir, who were the pioneers of the optical remote sensing activity in this country, they had become one of the major supporters of our micro remote sensing program. So in that sense, Kiran sir's contribution in optical remote sensing, various system designs related to optical sensors, whether it is optics or overall system, interfaces with spacecraft, and all related aspects starting from system design to these applications has been legendary and it needs no introduction. So thank you, sir, for accepting our invitation. He will illuminate us about the Earth observation sensors, both optical as well as something on microwave, and what is there in past and now what is going to be the present and future as far as these activities are concerned. Now, after Kiran sir's lecture, we have an all-rounder at the place, number 6, as they call it in a cricket 11, Dr. Goel Saab. Goel Saab needs again no introduction. He has been the pioneer of all spacecraft related and mission activities. And all of us know about Kalpana satellite and TES satellites, how he ingenuously volunteered and came out with a very excellent mission configuration for these two satellites. And his interest as well as his knack of these spacecraft and mission related activities are legendary, and his contributions to not only ISRO as well as Ministry of Earth Science as well as DRDO has again been well proven, and sir has been our greatest supporter as far as various activities are concerned, and we'd like to hear from him about the various IRS-1C and related spacecraft related and mission aspects. Anything is incomplete without it is like a marriage ceremony. After marriage is over, then other people are only husband and wife are left behind to take care of their life. In the same way, once the satellites are launched, afterwards it is applications which are the mainstay of the continuity of this program. And Dr. Naval Gun has been the pioneer of these various optical remote sensing and other associated application programs. So we'll hear from him about various application aspects of how IRS-1C was utilized and what is going to be the future challenges as far as applications are concerned, especially when we are going to open up the space sector. Dr. Silas Naik has been, we call it, an all-weather man, and he has been our mainstay of ISRS activities since last many, many years. And especially for journal for ISRS, he has been a great contributor and a great motivator for all the activities related to that, along with Dr. Josh sir. So we will be, as all of you are aware, that we are, ISRS is going to release this journal of a special issue on IRS-1C related activities. And we'd like to hear from Dr. Sailesh Naik, his experiences about IRS-1C, as well as how this GISRS is going to shape up. It is going to be released in January, and we'll hear from him about the various aspects of this particular journal. Our team here at Ahmedabad and other places, they have jointly worked out a very interesting memoirs about various IRS-1C related activities. So Dr. Mehul Pandya will present this activity and will bring out a souvenir type of a memoir for IRS-1C program. And anything is incomplete without the main people, Dr. Kalyan Raman sir and Dr. Ramratan sir. They had been the mainstay behind this particular IRS-1C mission. And all of you are well aware of that. Dr. Kalyan Raman has been the project director. Dr. Ram Ratan has been the associate project director here, taking care of all the payload aspects of IRS-1C. So they'll be illuminating us on the reminiscences of the IRS-1C era, what activities were carried out, how they were able to accomplish this really world-class payload those days, 25 years back. India is now famous for various Earth remote sensing satellites. When we are talking of today, sub-feet type of resolution, those days sub 10 meter type of resolution was really a very rare phenomena. So we'd like to hear from Dr. Kalyan Raman and Dr. Ram Ratan. Both have been a very tough taskmasters. And in fact, Dr. Kalyan Raman took a lot of interest in our program and gave a lot of suggestions related to our program. And in fact, we could imagine how people would have found it difficult to work with Dr. Kalyan Raman sir, with all his toughness and his insistence on various precision and smaller aspect of the program. So I thank Dr. Kalyan Raman sir for his valuable suggestions. And Dr. Ram Ratan is famous for bringing out everything to a logical conclusion. Dr. Ram Ratan sir, I welcome you and we would like to hear from you. I also thank and welcome Dr. D.K. Das sir, Director SEC, as well as Dr. Santanu Chaudhary ji for readily agreeing to participate in this program. Once again, we thank all of them for being present here. And I apologize to all the other contributors of IRS-1C program, because it is a playing 11. We can accommodate only 11 people here. So many of the very great contributors to IRS-1C program, we could not accommodate, but we would like to hear from them. We'll organize a special session for various similar submissions and they will get that chance there also. So once again, on behalf of ISRS and the organizers, I apologize to all of them who might be feeling that they have contributed a great to IRS-1C program, but somehow due to the time and other constraints, we could not accommodate them. And once again, I welcome all the dignitaries as well as all the participants who are watching this particular event on YouTube or other place through other social media events. And I request all the speakers to stick to their time if possible. We are not going to stop anybody, of course. In fact, I have eaten away almost 5 minutes from your program. So in that sense, your time is getting reduced by almost 30 seconds. So once again, thank you all for gracing this particular occasion. And I welcome on behalf of ISRS, all of you. And we are very eager and keen to listen to your memorable events related memoirs of this particular IRS-1C program. Thank you, sir.
Thank you, sir, for your warm welcome address. Today, we are fortunate to have amongst us former Chairman ISRO, former member of Rajya Sabha, Dr. Kasturi Rangan, as our chief guest. Under his dynamic leadership, India forayed into many successful missions, with the definition of India's first planetary mission, Chandrayaan-1. Sir has been instrumental as the head of the drafting committee of the new education policy. Sir has been conferred with several prestigious awards and is indeed our national pride. May we kindly request you, sir, to deliver your speech on the operational era in remote sensing, the IRS saga. Please, sir.
Thank you very much for this privilege. I would like to at the outset thank Dr. Shivan, Chairman ISRO, and also Dr. Nilesh Desai, the President of the ISRS, and then all the members of the IRS-1C community. Many of them are here today with us, speaking on this particular occasion. I would like to greet, and all others who are present here, I would like to greet all of them at this very august occasion, that of celebrating the silver jubilee of the launch of IRS-1C. I had initially a thought that I should say a few words about each of these people who are going to speak here. They were my most valuable colleagues. You minus them and there is no IRS-1C. So that is the kind of criticality that they have played with respect to the designing, the building, the testing, and evaluation, and ultimately its proof in the orbit. Each one of them had a very critical and singular role. So when Nilesh said that George Joseph came out with this idea that we should have this 25-year celebration, I think he was thinking of this kind of a thing, that it will be an occasion to remember them and all they represent in terms of people and the work culture that led to the IRS-1C mission. But before I say something about this, I would only like to say I'm so happy to see each one of them, whether it is George Joseph, who was actually the mainstay for any specific optical system. In fact, in a sense, he set up a parallel optical laboratory, which is probably, I used to always say, it is equivalent to the Perkin-Elmer's in SAC. And then you had Kiran Kumar, the wonder boy, who always came out with solutions where people were completely against a block with respect to resolution. He sees a particular functioning and he comes out with a total solution. That is Kiran Kumar. Goyal, he has a solution for everything, and he is the man who could bet with the chairman. When something chairman had skeptical, he was confident. And then he extracted a month salary from the chairman. But that turned out to be 1 rupee simply because of the fact that chairman was drawing only 1 rupee from ISRO. But then that's another story. But that is Goyal. And then you have got Dr. Naval Gund. No boot application loses, escapes his scrutiny. He is extremely critical, very much go for perfection and excellence. And therefore, the quantification of the remote sensing data, I think he is really the guardian that these numbers are the right ones. Shailesh, he has worked on some of the most difficult problems in remote sensing. The very low radiation that comes from the ocean and the kind of separation that you need to do against the noise, and thereby make OceanSat a meaningful, especially the the hyperspectral kind of instruments, to really catch up the radiation, say from the phytoplankton and those kind of ocean. I think Shailesh has played a very, very significant role in trying to create a capability in this country and thus bringing us to a world standard. I do, of course, don't know much about Mehul Pandya and Nitin Padalia, but I know that if they are here, then they mean something. Kalyan, I think I have to say something because he was my right hand, left hand, and everything. And at a time when I was not even well, he carried the formula. I should say he was not only just the project director, he was in charge of the whole program. That is Kalyan. And somewhere, Neelis said, he is a taskmaster. There is no question on that. He really wanted to get things done in time. And at the same time, he never forsook the issues of quality, reliability, and so on. I think, in a sense, he was a single point critical person in the success of IRS-1C. We not only, I am so happy and eager to see him. I don't see him very often nowadays, but then I'm very eager. But I know the criticality of his role in the context of IRS series itself and IRS-1C in particular. Ram Ratan, I think he's a legendary figure, if you ask me. Nothing is impossible for him. Optical sensors, and especially the kind of things that IRS-1C had to have, I think Ram Ratan played an extremely critical role. He had a strong basis on the optical remote sensing. He is very strong in optics. He is a student of Professor Ghatak in Delhi University, and he really has carried it forward. So I salute him today when I see him having realized a camera of this class. So the net result of these people is the fact that today, when IRS went up in orbit, IRS-1C, it was the best in the world. And there was in the civilian domain. And the history, the saga of remote sensing program, when you talk of IRS-1A and 1B, we build it with a very specific objective in the mind. We should catch up with a kind of capability that Landsat at that time had. And so that at 30 meters, we can have the rice fields and other things scheme, and 70 meters more as a replacement for a Landsat system, which is 70 meters. So we had that first level of ability to see the ground system, ground elements at 35 meters and 70 meters, one replacing or one working along with the Landsat, similar capability. And the second one, which is specific to India, the small sizes of the rice field and agriculture was one of the more important things. So that was the genesis. It was decided by George Joseph and others that we will go for a reflective, the refractive optics. Very good one, very good choice at that particular point in time, and very good optical efficiency and things of that kind, one of its kind anywhere in the world. The choice of refractive optics. And from then, that is the time at which we equaled ourselves with respect to Landsat system in some sense. But then the question that was raised, and I used to always hear this sound from among the other people in ISRO, maybe it is from SAC, that the question that was raised in one of the reviews was that we have built something which is world equivalent. But why always be equivalent to the best of the world? Why don't some people tell us, Americans tell us, French tell us, that Indians have built a satellite, let us emulate it because they have built the best satellite. So the 1C genesis, according to what I have heard, is that people, the engineers, the scientists in SAC and ISAC wanted a satellite where the Americans have to say, let us do this, and rather rattle them, rather than we getting rattled every time because somebody else does it. So that is the genesis. And what is interesting is whether it is in the context of optics, whether it is in the context of satellites, whether it's the context of the mission planning, and most importantly also to look at the various kind of choices of bands and so on. I think it was one of the things in which an end-to-end effort was made with thoroughness, a thoroughness and professionalism that was brought into right from definition of what the wavelength bands has to be included for the first time a near infrared region, and then a resolution which is something like 5.6 meters and 23 meters, and a certain revisit capability. These were made them so, and also an optics system. And in fact, I have discussed it threadbare on because I wanted to make a lecture of this in the academic science meeting. So I wanted to know what the IRS-1C pan camera was like and how did you reach the level of optics that it carried, a reflective optics, and that too non-centric reflective optics. You needed a wider coverage, and then of course the question of whether it should have a photodioptic configuration or a regular type of configuration. These were fairly involved design issues, and Kiran gave me an extraordinarily nice lecture on how exactly they arrived at. And then I had, of course, discussion with Dr. George Joseph. And if I go back several years back, is the time in which I had this discussion. But there is so strongly etched in mind, simply because of the fact that there were details which are so well thought of, so well explained, and so well implemented, and showed itself as the proof of the pudding when it went and put the images. A 5.5-meter image was so thrilling to see the kind of detail that it, whether it is in the north, the South Bombay tip, or a satellite, a kind of an image from some of the Middle East countries and things of that kind. They were extraordinary in quality, clarity, and of course in the application, their potential was unmatched at that time as a civilian satellite. So that is the kind of a thing. The SAC drove it, and the ISAC had, of course, after SAC drove it, ISAC had to build the control systems. That was also one of the most difficult part of it. Dr. Goyal played an extremely critical role in trying to make sure that we went on discussing about jitter and stability, and what really the ad nauseum keeps discussing. Do we go to get the real jitter? Whether we get, because we are talking about pixel, and the pixel wide resolution is so much critically dependent on the precision of the jitter and as well as the stability. So that kind of a thing. So we got a satellite which is capable of doing this. We had a camera system which was one of the unique in the world, which we built a reflective optics, which is and with the non-centric reflective optics, and the designs and development, testing, evaluation, and evaluation itself is a major task. These are all part of the IRS-1C saga. I want to say this beyond IRS-1C saga in terms of the reflection in the optics as well as the bus. The bus itself was something which we went into great detail. How well the bus, not only with respect to the design consideration of an optimal approach, failure mode analysis, and also looking at if a failure occurs in a particular way, what happens to the mission? Is there a way in which we retrieve back? And if that is to be there, is the provision to be built into the satellite? So these are the kind of things, and I think it was a marvelous thing. That is where I remember Kalyan, I remember Goyal, and many others who really came out with solutions with respect to addressing the failure modes so that a single point failure of the type which can be mentioned, for example, in INSAT, we don't repeat it here. And I think it proved itself. 9 years of life in orbit was a remarkable feat with respect to this. And I would like to say that this really was a saga of that particular thing. Why I consider all this is today, I think we have moved very much beyond the IRS-1C. We have also be the always we had this vision that we should go beyond the question of a single remote sensing system. We should even think of thematic satellites. Thematic satellites, but it could be a cartosat for mapping application. It could be a resource application, resource sat where you bring in really the major earth resources component of it. You bring in very high resolution radiometer sensors, which is used for meteorological purposes. You build a remote ocean satellite where you've got this the multi-channel, almost like hyperspectral systems, as well as scatterometers, altimeters, and radiometers, which is the ocean sat part of it. So, and then of course CatSat and so on and the other kinds. So in a sense, it is mutated. The basic IRS has mutated into multiple configuration, multiple application, more focused directions for applications. And today you have a whole host of satellite series which has come out of it. And what is interesting is one could see design of the bus in doing this kind of a thing. So the design of the bus was fairly robust with respect to its ability to adapt to different kinds of mission. And so today we are moving in that kind of a strength to strength with kind of 26, 25-meter resolution in a cartosat kind of a configuration is a one class of thing. This is all that at this particular point, but certainly we are entering into a new era. And I want to come to the chairman of ISRO, who has in the last 3-4 years has been moving ISRO in directions which was not what exactly it was before. First and foremost is, of course, improving the capabilities of land vehicle, perfecting the GSLV Mark III, and the questions of looking at the newer propulsion systems, kerosene, the kind of fuel or methane kind of a thing, more advanced semi-cryogenic systems. So the work on that also is progressing. The launch vehicle program has become much more focused and directed and well entrenched with respect to the futuristic requirements of more heavier system to be launched. So that is one aspect of it. And of course, the kind of vision that the present ISRO has got is to finally take it into a multi-ton kind of a thing, not even at 6 tons and 8 tons at GTO, but take it to 25 tons. And when world is looking at 100 tons, we are talking of this kind of a thing. So that is how ISRO is moving. On the satellite side, of course, it has grown several ways. I said IRS mutation strategy of this kind. Every satellite, whether it's the navigation system, now we should go into the next of the navigation systems. And then you have the communication satellite system, the older concept that we use, where you have to have frequency, you reuse, and many other kinds of applications where you have to create an optimality, much more autonomous capability on board and things of that kind. These are all now being tested with respect to the more advanced GSAT systems, which are currently being built. So that is one part of it. And then, of course, there are the scientific satellites. And what is interesting about scientific satellites is we have been able to advance, particularly in astronomy and astrosat, for example, several concepts of control system. You need exceptionally high pointing and accuracies, pointing accuracies, jitter accuracy when it comes to astrosat. We have to derive the considerable heritage from the IRS-1C and the follow-on satellites with respect to that. So that is the other part of it. And then, of course, it comes to the question of application. And application now slowly moving into a regime where there will be a lot of commercial activities on the IRS, on the application. I wish to say that Dr. Shivan has now brought in a restructured ISRO, which will facilitate more and more industries to get into it, more and more commercial activities to be a part of it, more and more of this kind of international systems coming together to get a final in expanding our own scope of activities here. And so there are several ways in which, and for that ISRO itself will have several types of structuring with semi-independent capabilities, but with an integrated decision-making system. And these are all going to reflect itself in the coming years as a major transformation to the way in which currently the ISRO is. And it was a timely step that ISRO has taken. I would like to compliment Shivan in this fora with respect to what has been done for ISRO. I think but it certainly show with certain time, but government is fully backing. I understand the Prime Minister took a personal review several times of the kind of restructuring that would help ISRO and also further grow the industries and then create a real commercial niche for ISRO's capabilities in a wider market, both within India and abroad. So he has given very specific direction to enable this kind of a thing, and he has promised the support. And I also understand in a subsequent months later, he was highly appreciative of the Shivan and team for having accomplished already the first steps towards moving towards this kind of a reorganized structure of ISRO. I think ISRO that way is now moving well directed, and certainly it has the framework in which we can see even bigger things happening, more challenging things happening. And so far as this community is concerned, all I would like to say is that we should not at a time when IRS was at the 1C, 1A, 1B, 1C, 1D times, I used to appraise Vajpayee was then the Prime Minister and he was our boss about the marketing. And I used to say that IRS today has a 40% sales in the global sales of imageries. And this struck the Prime Minister very much. So after two reviews, when we had a third review on the various aspects of ISRO's program, he asked me one question suddenly from his own, the recalling of his memory. What has happened that 40%, has it increased further? He asked. So this is the kind of importance he gave. We need to come back to that kind of a situation because today there is much more competition, much more sophistication in satellites. The ability to pinpoint a place on the earth and get it in 24 hours time is something which is quite realistic, and it is against this kind of an environment that we have to compete. It's not simple competition, but there is going to be a tremendous systemic effort that is needed to compete in this kind of a market. But ISRO having shown what it can at a time when one cannot dream of in the world, we dreamt of it and we achieved it. I think for that organization, nothing is impossible. And with the new policy of the government and what Dr. Shivan and his team has initiated, I think that combined with the ISRO's credibility and credentials, I think we should be able to reach levels where we will again come back to a preeminent position, even in creating innovative applications and also as one of the largest suppliers of remote sensing information for a variety of applications across the world. And I use this opportunity to congratulate all the members of the ISRO community, the present and the past, and also the youngsters who are sitting as the future ambassadors, as the future people. I wish them all the very best. It is a 2021 which is dawning, and I am sure the 2021 and beyond, our new resolution would be one that we will take the ISRO to even higher heights than we have ever imagined. And I wish all of you the very best in this effort. Thank you.
Thank you, sir, for giving us a nostalgic journey to India's remote sensing program and believing in us as a ISRO family to grow further. As a token of our gratitude, on behalf of ISRS, we'll now felicitate Dr. Kasturi Rangan in virtual mode. May we have the slide, please?
Thank you.
Thank you. A leader's actions inspires others to dream more, learn more, do more, and become more. Today, we are privileged to have amongst us an inspiring leader, a visionary, Chairman ISRO and Secretary Department of Space, Dr. K. Shivan, as our guest of honor. He has been instrumental in successful accomplishment of the first development flight of GSLV Mark III that launched India's heaviest satellite from our own soil and since then has been creating history. He is the chief architect of ISRO's space transportation and has been a guiding force for drawing technology roadmap for meeting the future requirements as well as augmenting the existing capabilities. May we request you, sir, to kindly deliver your speech on the title ISRO's Remote Sensing Vision for the Next Decade. Shivan, sir, please.
Most respected Kasturangan sir, who is identified as one of the people 2020 by Indian Express newspaper yesterday. Sir, it's all a proud moment for all of us for getting that such a great honor from the former chairman ISRO. And most respected Kiran Kumar sir, who used to diffuse my pressure whenever my pressure is increasing. And respected Goyal sir, always give some advices on the technical aspect. And respected Shalak Naik sir, former secretary MOES, George Joseph sir, former director SAC, and Naval Gun sir, former director SAC, and my dear friend DK Das, director SAC, and Sri Shandana Chaudhary, director NRSC, Mr. Nilesh Desai, associate director SAC and president ISRS, Dr. Kalyanam Raman sir, Dr. Ram Ratan sir, members of ISRO and ISRS family, good evening to you all. At the outset, I appreciate ISRS for organizing this event to commemorate the 25th year of the successful launch of IRS-1C mission. IRS-1C was one of the important missions of Indian observation program. We have just heard Dr. Kasturangan sir explaining how the operational era in remote sensing evolved in the country, which inked a remarkable chapter in the history of Indian space odyssey. In this remarkable journey, the year 1979 and 1985 marked two major milestones. 1979 witnessed realization of the Bhaskara-1, the first experimental terrain remote sensing satellite built and launched by India. And 1985 saw the establishment of National Natural Resources Management System, or NNMRS, which was the culmination of efforts of more than a decade towards operationalization of remote sensing applications. I just wanted to mention to all the members, after so many years, now once again the government is initiating the similar system with in our government system to make that remote sensing satellite useful for other ministries. Thankful for the initiation directed by earlier chairman. The satellite adopted for Earth observation program was enabled user ministries and departments in adopting or internalizing the technology by them. Joint utilization programs and application validation programs were accomplished before transferring the proven applications to the concerned ministries. Over a period of about 4 decades, we could realize necessary space infrastructure and associated ground segment for acquisition, processing, and dissemination of EO data and development of EO applications towards meeting the national imperatives. We have streamlined the resource series of satellites with 3-tier imaging as the workhorse for natural resources management, Cartosat series for very high resolution and stereo imaging, RSR series for all weather imaging, INSAT series for meteorological, and OceanSat series for oceanographic applications. UO applications have also matured to operational utilization in many domains for inventory, monitoring, decision support, and advisories. About 30 ministries and departments in the country have either institutionalized or internalized UO applications. A few such examples include Ministry of Earth Sciences, Ministry of Agriculture and Farmers Welfare, Ministry of Environment, Forest and Climate Change, Ministry of Jal Shakti, Ministries of Urban and Rural Development, etc. Continued efforts are made for wider dissemination of UO data and enhancing its utilization, governance, and development. So, there is growing demand for open availability and easy access of satellite data for facilitating the greater involvement of stakeholders for the value addition and innovation. Also, the role of private entrepreneurs is important and mutually beneficial, where they exploit the commercial prospects, and ISRO focuses on developing newer technologies and applications. In addition, the prevailing global scenario and government's initiative towards self-reliance India, that is Ahmedabad Bharat, also call for more liberal mechanism. Addressing these aspects, we are bringing path-breaking changes in UO domain through the proposed space-based remote sensing policy. First, the UO data and products from IRS satellites are proposed to be made available on free and open basis to the users. Secondly, we are operating the UO sector for private players who can engage in the entire gamut of activities, right from owning and operating space infrastructure to dissemination of data, value-added products, and services. In 2018, we have conducted national level consultations with the stakeholders of UO system in the country and brought out the plan for the coming decade. The expert committee, under the guidance of Dr. R.R. Navalgund, spearheaded the interaction with the nearly 100 experts across 28 user departments, and the APAS committee, under the guidance of Dr. B.S. Goyal, translated the user demands into realizable and optimal UO missions. Nearly 30 new UO satellites would be required for meeting the demand across the various application domains. These encompass about 30 optical payloads and almost equal number of microwave payloads. The fourth generation ResourceSat series would also be having multi-band SWIR and thermal imaging capability for supporting applications of natural resources, ecosystems, and water balance. Exclusive missions in inclined orbit for thermal imaging of forest fire and coal fire mapping would help near real-time monitoring of fire episodes. A constellation of C-band synthetic aperture radar satellites in inclined orbit would provide timely inputs for disaster management. The data from our scatterometer mission is globally acclaimed and operationally assimilated, and we would be enhancing it with dual frequency scatterometer mission for tracking cyclonic winds with greater accuracy. Along with this, the K-band, the altimeter mission, would give further impetus to ocean observation capabilities and would be complemented by the third generation OceanSat series of satellites. Microwave sounder mission for temperature and humidity profiling of atmosphere would provide continuity to the SAFIR data, while the fourth generation INSAT series satellites with advanced imager, hyperspectral infrared sounder, and lightning detector would augment the weather forecasting applications in the country. Technology development would be attempted for the new space-based observation capabilities such as dual satellite expand interferometric SAR mission, wind LIDARs, gravity, geomagnetic soil salinity measurements, etc. Need for monthly systematic coverage of the country as well as daily revisit of areas of interest at very high resolution would be met through constellation of satellites. In terms of UO applications, our primary focus would be continuity of the operational applications with improved accuracy, scale, and frequency. Some of the specific areas of applications would involve technique development for production forecast for minor crops, crop insurance, hydro-informatic products, mineral exploration, hectare scale biomass assessment, CT scale model for particulate matter, reflectometry and radio occultation based products, etc. Onboard processing, cloud-based computing, AI and ML-based data analytics, analysis-ready data, etc., would enhance information and the scientific content and its timely dissemination. The synergy of data and services from UO, communication, and navigation satellite, along with processing platform, would provide enhanced support towards governance and development. I'm sure that these efforts would reinforce ISRO's vision of harnessing space technology for national development. Thank you, and let me wish all of you all a happy New Year. It is going to be very nearly. It is going to come. Thank you, Jai Hind.
Thank you, sir, for motivating us with the brilliant prospects of Earth observation remote sensing. We now request Scientific Secretary Sri R. Uma Maheshwaran, sir, to felicitate guest of honor Dr. K. Sivan on behalf of Indian Society of Remote Sensing. Please, sir.
ISRO headquarters.
Thank you, Uma Maheshwaran, sir, for doing the honors. Thank you, Shivan, sir, for your kind acceptance. It's very well said. The soundness of a structure relies on the foundation laid. We are honored to have with us one of the pioneers in the field of Indian space program and former director of Space Application Center, Dr. George Joseph. So started his research career in 1962 at Tata Institute of Fundamental Research in Bombay, where he was involved in the study of cosmic rays. A novel detector system designed by him was flown on the first Indian satellite, Aryabhatta, to detect solar neutrons. In 1973, Sir was invited to join the Space Application Center, ISRO Ahmedabad, and initiated the development of remote sensing technology, particularly electro-optical sensors of various types. He has been the guiding force in the design and development of all the Earth observation cameras on board Indian remote sensing satellites and sir to deliver an overview of IRS-1C program. Please, sir.
Dr. Kasturirangan, Dr. Shivan, and other dignitaries, good afternoon to all of you. Stable platform, the kitchen platform was used to develop optical head. Well, this kitchen is the ancestral home of the state-of-the-art electro-optical sensor laboratory, now SAC has, producing world-class electro-optical sensors which image the Earth, the Moon, the Mars, and many more celestial bodies in the future. I just, before coming here, I had the privilege of visiting the new sensor laboratory at SAC. I'm amazed by the tremendous advancement in the technology made by the team, and my compliments to them. It is worth recollecting the Earth observation sensor development activity at SAC. The first effort was to develop a multispectral scanner for aircraft which used conventional optomechanical scanning technology. The aircraft MSS was extensively used to understand the potential of multispectral data for various applications. SAC payload team was forward-looking at the advanced technology for Earth observation camera system and initiated in 1975 a program for developing an aerial camera using CCDs based on the push broom technology and successfully flight tested in 1980. It is interesting to trace the global scenario of developing push broom technology based CCD cameras for Earth observation. The first airborne camera was flown in 1978 by DLR, German Aerospace Agency. In those days, when the internet was not as widespread as now, the percolation of information was very slow. Nevertheless, we was concurrent with the rest of the world to master the new technology. During the period when ISRO decided to go for an operation for space-based Earth observation was optomechanical scanners. The office order of then Chairman ISRO setting up IRS program envisaged a payload system consisting of multispectral scanner or MSS and the CCD-based imagery camera, which we call LIS for the linear imaging self-scanning sensors. Based on a detailed study, I proposed the advantages of going in for an all-LIS system for the first IRS mission instead of a combination of LIS and MSS, which was accepted by a committee set up by Director ISAC. Though my proposal to have an all-CCD configuration for the first operational Earth observation satellite was accepted by the committee, it is the foresight of the higher management, especially Professor U.R. Rao and Dr. Kasturi Rangan, to finally agree upon the selection of all CCD-based push broom technology. They should be complemented to see through the potential growth of CCD for high-resolution imaging, though the technology itself was in the infant stage. This decision was a game changer in satellite-based remote sensing in the country. But for this decision, the high-resolution camera on board IRS-1C would not have happened so early. Now let me give the story of IRS-1C, how the parameters were selected, and we have had a unique satellite at that time. The configuration of IRS-1C was decided during a review meeting conducted by then Chairman ISRO, Professor U.R. Rao. After hearing the rationale for having an additional middle IR channel for the multispectral LIS camera, he asked, what about the panchromatic band? Someone commented, we should have a 10-meter spatial resolution camera as in spot. His immediate response was, do not try to follow, we should lead. He said, I quote, I am tired of hearing that we are the 6th country in space. In the case of remote sensing, I want us to be the first country and let us try for achieving 5 to 6 meter resolution in the next IRs. Unquote. I am sure he was conscious of the need for having a higher resolution data for the application in the Indian context. He turned to me and asked, George, can you make a camera with 5 meters spatial resolution? Though at that time, I had no idea of the technical issues involved, I said that we will do it. It was a big challenge, since there were no past system in civilian Earth observation satellites providing such high resolution. But the team at SAC took the responsibility and accomplished a state-of-the-art camera system. The moral of the story is, you give a challenging task to the team, they will rise to the occasion and meet it. And this motto, you can see many achievements in the ISRO. Apart from the highest resolution provided by IRS-1C, it had another innovative payload, the wide field sensor, WIPS, providing a wide swath about 800 kilometers and spatial resolution about 180 meters. The thought of having such a unique camera was based on the need projected by the application scientist. Excuse me, I have some age problem. The study of the application scientists at SAC to estimate crop production before harvesting has shown that the time of the data acquisition during the crop growth progression is one of the important parameters which control classification accuracy. This requires a sensor which can make frequent repeat observation of the same area. The novel sensor WIPS was conceived to meet this application requirement, which with multiple overlap could get repeat coverage of a target of interest of 5 days. The point I want to make is we make sensors which meet the application needs. I will elaborate that a little later. Let me take this opportunity to point out that the specification of all the sensors were evolved to meet the requirements of the application scientists who were directly working with the end users to demonstrate utility of using IRS data to tackle specific problem. The sensor development team in turn interacted with the application scientists at SAC and evolved the parameters for the sensors. The follow-on to WIPS, the Advanced Wide Field Sensor, or we call AWIPS, with about 5 meters spatial resolution in ResourceSat-1, launched in 2003, was well received by the national and international remote sensing community. There are a number of publications you can see by the international scientific community. Even now, AWIPS with visible near and mid-infrared bands is unique compared to other current operating system. Let me now just elaborate the core principle on which we have been developing our payloads. While we can be proud of having a series of Earth observation systems, what is important is how the data is used to meet the end user requirement. ISRO from the beginning was very conscious of having a close dialogue with the end users. Professor Yashpal, the first director of SAC, conceived to have all components of remote sensing under one roof so that close interaction takes place between experts of different disciplines. He also realized that while ISRO is developing the remote sensing technology, there should be an organized way various end users can be brought into the loop. He created a nucleus for this activity named user cell. This is very unique anywhere in the world. The mandate for the user cell was to appraise various departments on how remote sensing input can help them to tackle problems in a timely and expeditious way using specific examples. Thus, the user cell acts as a link between the technologists and the end users. Later, ISRO established the PCNNRMS. The various working groups under it facilitated the involvement of all stakeholders to ensure that remote sensing benefits percolate to the end users, and also as partners setting up requirement for future space system. ISRO also carried out remote sensing application jointly with end users to demonstrate the potential of remote sensing for their discipline. I would narrate that even before the satellite were launched, we were application program. If I remember correctly, the Bhaskara utilization program was done simulating data from the NOVA. Similarly, we had IRS utilization program, so on and so forth. I hope the culture is still continuing. I would like to mention from my very limited understanding what our future system for IRS or future activity of IRS remote sensing in general. We should be conscious that over the years, there are two major shifts in remote sensing activity. This is the way in which I look. Maybe I am an old timer, may not be right. It is time we now realize that compared to 70s and 80s, the present day user community is well aware of the potential of remote sensing information for their specific application. They are no more interested in just data, but looking for how the remote sensing information can meet their application needs. That is, they are looking for how remote sensing can be used to provide solution to their problem, which requires integration from other data. Remote sensing alone does not provide any solution. To meet such demands require development of analytical tools and models to address specific problem. The success of, according to me, the success of a remote sensing program will depend on how the application scientists become solution providers. I understand that more than 50% of revenue from remote sensing activity is from the use of remote sensing data rather than generating it. This is an area where private entrepreneurs can play a substantial role which they could have played even before the new space policy. Another aspect which I understand from the going through the literature and data is the availability of data. 11 bands Landsat 8 data is available free. Landsat 8 real-time process data with estimated radiometric and geometric calibration is available in less than 12 hours. In addition, archived geo-reference data, what they call ARD or analysis-ready data, is also available free, allowing analysis with a minimum of additional user effort. I think this data is, the next is the ESA data. ESA remote sensing satellite Sentinel provides globally 13 band with a 10-meter resolution free. We need to critically assess what should be the capability of our next generation IRS satellite. We have to be innovative to beat these things and come out with the new ideas. I used to say, and I will repeat, our aim should not be to make the best remote sensing satellite, but realize payloads that are best suited for our national needs. In doing so, we may make the best satellite also. This requires the full participation of all stakeholders, right from the concept to validation. The various working groups working under the IRS, under the PCS and RMS, were one such avenue to understand user requirement in earlier times. I hope such activities or such work is currently also going on. My best wishes to remote sensing community to continue to contribute to remote sensing technology and application to meet the national needs. Thank you.
आपका हार्दिक आभार सर. We thank you for reminiscing with us the IRS-1C memories and taking us on your thoughts about the future of remote sensing program in India. मैं निवेदन करना चाहूंगी डायरेक्टर सैक श्री दास सर से एवं एसोसिएट डायरेक्टर सैक श्री देसाई सर से कि वे जॉर्ज सर को ISRS परिवार की तरफ से सम्मानित करें.
Waiting for action. Waiting for action. Uh-huh.
Yeah, you can continue.
Thank you, sir, for doing the honors. Thanks, George, sir, for gracing the occasion today. ISRO's space program has established India at a dominant position in the League of Spacefaring Nations. India now has its eyes in the sky across a multitude of wavelengths, making continuous observations in multiple dimensions. Former Chairman ISRO and former Secretary Department of Space, Shri A.S. Kiran Kumar, is known to have made contributions to the Indian space program since the early days of Bhaskara mission, IRS series, till the popular programs such as Chandrayaan-1 and Mangalyaan. Sir is credited with the design and development of the gamut of electro-optical imaging sensors used in India's various remote sensing satellites. We are humbled by your presence, sir. May I request you, sir, to please address the esteemed gathering on the title Earth Observation Sensors IRS-1C, Present and Future Scenario.
Thank you very much for that introduction. Dr. Kasturi Rangan, Dr. Shivan, Dr. George Joseph, and all the colleagues and participants of this unique program conducted by ISRS along with the Space Application Center to remember the launch 25 years ago of Indian remote sensing satellite IRS-1C. We all remember how we started, as Dr. George Joseph mentioned, development of optical systems at the Lena Apartments in Ahmedabad and in the kitchen laboratory. Starting from that point, when we reached after completion of IRS-1A and 1B, as again Dr. George mentioned, that at the time of 1C, Professor Rao was looking at when we can break the barrier of being called we are second, we are third, fifth, sixth, etc., how we can become comparable to the best in the world. And that is when this particular imaging sensor of providing a spatial resolution in the civilian domain better than the best available was being talked about. And it was at that time we were looking at within the resource constraints of what was available in the launch vehicle, our PSLV, the kind of satellite it could carry, and within the confines of that satellites, both in terms of volume, weight, and power, how to build a telescope which is actually better than what was currently available. At that time, the yardstick was the telescope available on the Spot satellite, which was almost a very large volume system, and such a telescope could not have been accommodated on IRS-1C, IRS platform. So we were really looking for how to break this barrier, and at that time we realized that the literature showed that 3-mirror anastigmat, a very compact telescope which could provide very high spatial resolutions, is possible, though the literature had mentioned that nobody had attempted to build such a telescope at that point, at the earlier era, simply because of the complexity that existed in realizing the kind of surfaces that were required for the mirror systems. And when we looked at this particular design, we realized that if we are to meet the challenge of what Professor Rao is asking, to build a compact telescope within the IRS satellite bus, the only way available to us is to adopt this 3-mirror anastigmat telescope system and then realize them. And like Dr. George said, when he guaranteed to Professor Rao that we will build a telescope or we will build an imaging system which is capable of doing that, what we had taken up as a challenge was something we were not sure what we will achieve. But then when we realized that this 3-mirror anastigmatic telescope is the way to go, we had completed the design of that. And initially our plan was to realize these mirrors also in LEOS, and Dr. Alex was very confident that we will be able to realize them at LEOS. But then as the time, the efforts went on becoming more and more difficult for realization of the mirror, we found that it was possible to get these mirrors fabricated in a French company, and that French company could make this to our design. And in fact, I would like to just quote a small episode here. Initially, the company which had interested in making these mirrors had been building telescope optics for spot. And when we floated this requirement for fabrication, they were very skeptical that it is possible to realize a telescope of this kind of resolution and performance in such a compact dimension. Initially, when they came for evaluation of the proposal, we had not parted with the design, and they came here with their own computing system. And as part of the initial evaluation, when we gave the design to them, they went through their analysis, and at the end of the analysis, they realized that it was something which was actually producible or manufacturable, and they accepted the challenge. And that's how initial set of mirrors for this telescope, a very compact system, was built. And in fact, I remember later one of the meetings, the chief executive of that company told me, after we had launched the IRS-1C and the 5-meter images were available in the globe, the French government had asked this company, how is it that India is able to do this, and in France itself, which has produced these components for them, has not achieved this kind of resolution. So they were in for a little bit of struggle at that time to explain to them how things had happened. But what I just want to mention here is that here was an opportunity, a challenge posed of achieving a performance better than what others had done. And this is where the approach of leapfrogging and technology usage comes into picture. And true to what Dr. Vikram Sarabhai had been envisaging, how to bring in the advanced technology, here was an example which was shown that if you look at the current capabilities, while the initial design was not taken up for fabrication for want of manufacturing difficulty and alignment complexities, we realized that at that point of time in the early 90s, it was possible because of the interferometric testing methodology and 5-axis robotic machine polishing system that such mirrors could be fabricated. And we went ahead and realized this. And it was this unique capability of looking at newer designs and adopting those concepts which helped us make IRS-1C a very new and very capable remote sensing system. As has already been pointed out, this particular telescope achieved in almost 1/8 the volume of what SPOT did, 2 times better resolution. And in this, we also made use of an advanced CCD technology, one of the very small pixel size, only 7 micron pixel size device was used with 4096 elements. And then the complete 3-tier imaging system concept design, which got evolved, capable of providing for phenology studies, high temporal resolution and low or coarse spatial resolution AVIFs, along with LIS, which was providing medium resolution both in spatial and temporal, and very high spatial resolution with coarse temporal resolution IRS-1C panchromatic camera. And it was this combination which was actually realized, and this concept of 3-mirror anastigmat actually was taken forward. And today we have more than almost a dozen telescopes realizing them, and also providing later what is called as a Cartosat 1 series, which again provided one of the best stereo imaging systems in the world, and which provided for a very long time a data set for producing digital elevation models for not only our country, but also for the entire neighborhood, which is being very preciously used today under the demanding conditions of various strategic applications and non-strategic applications. In a nutshell, what IRS-1C demonstrated was that you can take up challenges, you can do leapfrogging, all is possible provided you have the support from the management, and also the people who are doing the work are given the freedom to visualize and realize that. And this attitude of ISRO is what has enabled ISRO to perform. And today, as we see the progress on this, the three-tier imaging concept is being enhanced. In fact, any imaging observation that is done has 4 resolutions: radiometric resolution, spatial resolution, and then spectral resolution and temporal resolutions. And in all of this, ISRO has made an impact. Today, we have systems which can produce images of India of the order of 100 kilometer by 100 kilometer, few times a second from geostationary platforms. We can provide hyperspectral imaging at little coarse spatial resolution, but very high spectral resolution. And then you also very high spatial resolution Cartosat 3 series data. And in fact, not only in the optical imaging, we also have established today in the microwave systems, not only in polar orbit, but also in inclined orbit, wherein the data set that is generated from these imaging systems is providing for the various requirements of national development, including strategic and also atmospheric observations. And another key thing is the world recognizes you for your demonstrated capabilities, and what ISRO has shown is both in terms of the microwave systems, and today when India is working along with NASA for the NISR, and then along with many other French and European Space Agency systems for missions where we are working on equal terms with them, has happened because of all these capabilities. On this occasion, I would like to compliment the entire management system at that time, which believed in the capabilities of the youngsters and then paved the way for making India a force to reckon with in the imaging systems in various aspects. So thank you very much for this, and also let me compliment ISRS and Space Application Center for conducting this event. And it just reminds me as though it was yesterday that we were working in the laboratory trying to assemble this 3-mirror system and then going through the whole process of realizing the performance. But time flies, and today we have already completed 25 years, and now we are looking ahead where the world has moved on. And today the global capabilities is almost on a daily basis, the entire globe can be imaged at various resolutions, and people are looking at from geostationary platforms achieving maybe a few meter resolution imaging system, and also providing microwave capabilities for this. So thank you very much, and I compliment ISRS and Space Application Center for remembering events like this and motivating the next generation. Thank you.
We are thankful to you, sir, for sharing with us the story of IRS-1C sensor development and the long journey that sensors of ISRO missions has come. May we now request Scientific Secretary Sri R. Uma Maheshwaran, sir, ISRO Headquarters, Bangalore, to felicitate Sri A.S. Kiran Kumar, sir. Thank you, sirs. We are pleased to have with us today Sri Prem Shankar Goel, former Secretary at the Department of Ocean Development, Ministry of Earth Sciences, Government of India, and a former Director of ISRO Satellite Center. Sir is a renowned space scientist who had an elaborate career in ISRO and has contributed immensely towards attitude and orbital control subsystems for the myriad of Indian satellite programs. Over the years, Sir has served as the chairman of the Spacecraft System Advisory Board for IRS-1 satellites. Sir was the first chairman of the Earth Commission a global forum of scientists. May I request you, sir, today to deliver your talk on IRS-1C, spacecraft and mission, and future challenges. Please, sir.
Goel sir, can you unmute? Sir, can you unmute your mic?
Sorry. Thank you, ma'am, and good afternoon to all of you. Dr. Kasuranganji, you reminded today a very long association starting from Aryabhatta, Bhaskara, IRS-1A series to 1C and all that. I remember as if we have lived in this few minutes of your talk, as if all this some like 40 years of journey. Dr. Sivan, our association for the IRS-1C was only in the context of launch vehicle, and you remember we were talking of a salvaging mission in the PSLV capability which we had incorporated. Dr. Kiran Kumar has been our, say, one of the best system engineer payload. I always remember Dr. George Joseph, along with Dr. Kiran Kumar, Dr. Ram Ratan, and Nakchin Chaya as a kind of a pioneers in the optical payload capability. Mr. Kalyanaman, our project director for IS-1C, and we worked so closely for such a long time, particularly in the IRS-1A, 1B, and 1C, etc. Today we have Dr. Das, Director SAC, and Dr. Shantanu Chaudhary, Director NRSA, Sri Nilay Desai, President ISRS, and also many colleagues from the, I can say, our IRS-1C team were there. Welcome to all of you. First, let me thank Sri Nilesh Ji for and ISR in general for organizing this event. Function is a very important milestone for ISRO in terms of IRS-1C. And why I say it's a very important milestone, because when we look at the remote sensing journey of ISRO, our Bhaskara was a sort of, we call it experimental mission. IRS-1A, 1B, we always call it an operational mission for remote sensing in ISRO. But IRC-1C gave a leadership, and this is what has been elaborated by Dr. Rangan, Dr. George Joseph, Mr. Kumar, all of you, that it provided leadership, and thanks to the direction from Professor Yuva Rao, who was actually our, you can say, guiding light all these years. This 23 multispectral and 5.8 panchromatic, to us in the satellite team, and of course AWIFs, the most challenging thing was how do we provide a platform which is stable enough, does not give jitter, does not create a distortion of the images. And that's in this process, I would have spent a lot of time in trying to understand how the imaging takes place so that the spacecraft motions does not distort the imagery. And that was a quite sort of understanding to us. The key features, part of IRS-1C in terms of the satellite, were a high bit rate data system. And in those days, our internet, what we talk today of 100 megabits per second, or sometimes even 1 gigabits per second, in those days we used to talk in terms of kilobits per second. And thinking of 125 megabits per second as a data rate from a satellite was a very, very difficult task. And on top of that, managing at that data in the data handling system. And it's the first time we were actually recording the data in a tape recorder, which was a very special tape recorder for 14 channel, because we were to acquire at such a high data rate. Also, we first time did in X-band such a high data rate, and our team in the communication side came up with a very unique design of antenna where the range compensation will be done by the shaping of the antenna gain itself. So there are many new things. For the first time, actually, we had a area-based star sensor from Dr. Alex's team. We also were having a lot of
new development mechanism. First time we were having such a heavy payload and also having a capability to orient that payload, particularly the high resolution payload panchromatic camera, plus minus 26 degree. So there were some of the very new technology challenges which we had incorporated in IRS-1C. I remember a very interesting incident that happened related to this satellite. In year 98, around 98, 99, we had a visitor, the chief of Russian Space Agency. He came to Isaac. We took him around, showed him IRS-1D under development, also IRS-P4. And we had a discussion. We showed him the pictures of IRS-1C. And at the end of the visit, when he came to my room, and he said, he made a statement that ISRO is 10 years ahead of Soviet or Russia in terms of remote sensing satellite technology capability. Now, that was a very interesting comment, particularly the context is that in 1982 or 83, a 3-member delegation was sent by ISRO to Russia to understand the technology and whether there is a data processing capability for remote sensing satellite. We were actually not aware, and the team was Dr. George Joseph, Dr. Ravidas Sharma, he was scientific secretary at that time in ISRO headquarters, and myself. We were not shown much there. They didn't show any hardware, just some, you can say, very scanned view of showing some of the capability of data processing. But the point is that we went there in 1982-83, and after 15 years, the chief of Russian Space Agency said that we were 10 years ahead of them. This was probably one of the best compliment I can say I heard about IRS-1C. Of course, as we have realized, that was the best satellite in the world at that time. Of course, this has we have made a lot of progress in these last 25 years. Dr. Sivan has very detailed way elaborated the exercise of planning for the next 10 years. We have looked at the requirement of the satellites and planned in a very detailed way also. But what is important is not just the space segment, but how to make use of it. And I totally agree with Dr. George Joseph. The current user, the present user, does not look at the data alone. It looks at the solution. And the solution do not come from data from just space. In fact, within space, it comes from the multiple satellites. And also a lot of ground truth, a lot of ground data, and it has to be merged. And this is where I personally believe that we need to focus in the future that how we are going to provide those solutions which are really required for, because the user doesn't want to get through the nitty-gritty details of doing this. It's a very small, complex task, and this is where we have to really work for. Otherwise, I would really say that we have really got the grips of what exactly need to be done with this for the space segment. Let me stop here and thank Mr. Desai and also ISRS for really organizing this event, which really reminds us, takes back to the memory lane of 25 years. Thank you very much.
Thank you, Dr. Goel, for taking us down the memory lane and apprising us about the challenges faced during those times. It's inspiring to hear from you, sir. As a token of our thankfulness, we'll now like to felicitate Dr. Goel in virtual mode on the behalf of ISRS family. Thank you. Indian space program had a humble beginning from a church in Thiruvananthapuram, and since then it has glorified year after year under the leadership of visionaries who have chalked down the path of success. We are fortunate to have with us today Dr. R.R. Navalgund, former Director, Space Application Center and National Remote Sensing Agency, Department of Space. Sir has provided leadership in evolving and executing national level remote sensing applications program in the fields of crop production forecasting, watershed development, groundwater prospects, ocean color, coastal management, and district level planning. Sir has been a constant guiding force in defining the path of India's remote sensing satellite program. May I request you, sir, to please share your thoughts on remote sensing applications with IRS-1C and its future perspectives.
Am I audible? Thank you. Thank you for that kind introduction. Dr. Kasturangan, Dr. George Joseph, Chairman ISRO, D.K. Das, Director Space Application Center, Shantanu Chowdhury, Director National Remote Sensing Center, all distinguished speakers who have spoken before me, as well as those who are going to speak after this my brief talk, as well as friends and colleagues who have been participating in this online function. A very good afternoon to each and every one. It's a great pleasure for me to participate in this event. IRS-1C in many ways was a game changer. Nearly I speak on IRS-1C applications and future perspectives in the background of celebrations of IRS-1C since its launch 25 years ago on this very day. In such functions, it is somewhat advantageous to be the last speaker or the last but one speaker, because whatever needs to be said has already been said by the earlier stalwarts. But for the sake of completion, I would like to make a few remarks briefly on the IRS-1C, and also perhaps tell you a few anecdotes of this IRS-1C. I think it would be more meaningful to talk about what value addition data from IRS-1C provided to overall applications than IRS-1C applications per se. Because remote sensing applications and their data requirements were very well known since the late 70s and the early 80s. Because we had the joint experiments program, we have the end-to-end experiments which ultimately culminated in the establishment of National Natural Resources Management System. We have also had the IRS utilization program very well defined. In addition, there were a large number of major national level application programs related to national crop production forecasting, integrated mission for sustainable development on watershed basis, wasteland mapping, coastal zone regulation. Many of these applications were already there in the offering, being executed with the data which is available from our own satellites to some extent and also internationally. While IRS-1A and 1B followed known broad specifications existing for remote sensing satellites at that time, like Landsat, IRS-1C was to a large extent more tailored to meet specifically some of the needs of the Indian scenario. In that sense, IRS-1C is a unique system. Inclusion of shortwave infrared band to quantify moisture stress in vegetation and to facilitate better snow cloud discrimination were two important value additions in list 3. It was also configured to have 23-meter resolution vis-a-vis 36-meter which was existing in the earlier list 2. This meant field parcels half the size than earlier could be detected since the pixel area came down by half. So crop area estimation improved considerably. One could also quantify reduction in crop yield through some vegetation index involving shortwave infrared data and also drought assessment. However, snow cloud discrimination did not do so well. Of course, that is because the gain settings and the saturation radiances were set more specific to crops. Of course, the blame for this was mine, since I was the chair for setting up this saturation radiances and gain settings because we were more interested in the agricultural applications. We also lost the blue band data because of shortwave infrared band had to be accommodated in the overall structural configuration of the payload itself. This, of course, prevented some of the applications related to estimating turbidity in coastal waters as well as in lakes. Now, frequent revisits is a major requirement in case of dynamic phenomena, including crop estimations. The WIFS wide field sensor, which was providing 5-day revisit as well as 2-band, having 188 resolution, was very useful for estimating total cropped area, not necessarily individual crops, unless those crops were grown in very large homogeneous area. Of course, this was a much better proposition than the data which was available to us from NOAA of 1 kilometer. In this regard, I remember an interesting anecdote. Dr. Kasturirangan and Dr. George Joseph had taken me along to a meeting with Professor U.R. Rao, the then chairman, ISRO, for taking a final decision on the inclusion of shortwave infrared band in list 3. You know, getting shortwave infrared detectors was an expensive proposition. We were not happy. I mean, the people from the applications area were not very happy that shortwave infrared is only included in the list 3, but not in wide field sensor. I also was not happy that the wide field sensor had a very coarse resolution of 188 meters. So in this meeting, which was wherein we were to meet Professor U.R. Rao, I wanted to tell Professor Rao, mustering enough courage, that it must be included in WIFS, shortwave infrared band, as well as the resolution must be made more adequate. But both Dr. George Joseph and Dr. Kasturirangan prevailed upon me not to express my view to Professor U.R. Rao there in the meeting. And maybe they were a little apprehensive. After hearing this, Professor Rao might say, then let's not have WIFs at all in IRS-1C. So anyway, I must admit, but this idea of having a very wide field sensor finally got realized in IRSP6, that is ResourceSat 1, in which we had the advanced wide field sensor. So in that we had 4 bands, including the shortwave infrared, and also we had the resolution from 188 meters to 56 meters. But Dr. George Joseph did not leave me. He said, you must do a large amount of simulation exercises to show why you require 50 to 60 meters with 5-day repeativity and not 188 meter, why it will not do just like that. So quantitatively, we had to estimate and make simulations to make sure that advanced wide field sensor could have these kind of specifications. Now, this was launched in 2003 while I was at the National Remote Sensing Agency. At that time, it was called National Remote Sensing Agency, not the National Remote Sensing Center as it is known today. But most of you know this advanced wide field sensor became extremely useful, popular, and I must also add that it became a workhorse sensor for even the United States Department of Agriculture for their world acreage estimation for different crops. I think inclusion of a relatively high resolution pan camera in IRS-1C was the most important contribution. As I have pointed out, there was only 10-meter panchromatic data available from spot at that time. Pan camera data allowed us to map urban sprawl and also make perspective plans. For the first time, a perspective plan for Ahmedabad Regional Development Authority 2012 was prepared at SAC sometime in 1996 itself. Chairman, Ahmedabad Urban Development Authority, came over to SAC to receive the report from Dr. George Joseph, the then director SAC, and very much appreciated the inputs. This had its own benefits in our interactions with the civic authorities at that time, who were forcing us to part with some of our land to expand the roads in front of our campus at Ahmedabad. I do fondly remember on this day my colleague and friend, Dr. Subhan Khan Pathan, who was responsible for generating this perspective plan for AUDA. Tragically, a few years later, he died collapsing at the podium while addressing a symposium at Srinagar, University of Srinagar, talking about the perspective plans he had made for different cities, including Ahmedabad. For the first time, pan-sharpened list 3 products became available and helped in many large-scale applications like coastal zone, watershed, etc. Pan-sharpened list 3 images for the entire country will also used in another very important project called GCP library, that is the ground identification of ground control points at a reconnaissance level. As many point out, we are good in jugaads. This pan camera later morphs into the 3-band multispectral LIS4 camera in IRS-1C. I must mention here, while introspecting, there were a few issues with data processing as well. There were odd-even radiometric imbalance in one of the LIS bands, image ghosting in wide field sensor, and visibly disturbing striping in pan, all hindering the use of these sensor data for ultimate intended applications. The mosaicing of 3 pan strips separated in the along track direction brought a latitude dependent problem to resolve for data processing team. Each of these was first of its kind. I fondly recount excellent efforts made by the data processing team at the Space Application Center, led by Dr. K.L. Majumdar at that time, and facilitating better utilization. He may be there in the audience. Let me salute him for these great efforts as well. In some instances, in view of this problem, we had the average of 2 pixels resulting in 46-meter resolution instead of 23 meters. I must lightheartedly quote a comment made by a senior colleague of mine in the applications area. Sir, we have a list 2 camera, list 2.5 camera instead of list 3. Dr. George Joseph was very gracious in accepting it and smiling away. Launch of IRS-1D, identical to 1C in many respects, within a couple of years, that was in 1997, helped in providing data at more frequent intervals, for some time providing enhanced applications. IRS-1C provided the right direction and ideas to configure future missions with multiple resolution sensor systems to meet the challenging needs of the stakeholders. As far as the future perspectives are concerned, I must mention a couple of years ago, Chairman ISRO, Dr. Shivan, had asked me to chair a meeting. I had the privilege of chairing meetings of a large number of users and stakeholders from all disciplines and sectors, both in Delhi as well as in Bangalore. Data required, sensors to be configured, and missions to be accomplished were very well defined. They include missions who are required for meeting the needs of operational applications, which are very important as far as India is concerned, notwithstanding the availability of international data from international missions. Then also address the needs of climate change, global change, greenhouse gases, and such many science missions, as well as many of the experimental missions which will enhance our technology and science efforts. So there is a gradation in the idea of these various missions. In addition to them, there is also a constellation of satellites, particularly as Chairman ISRO mentioned today afternoon about the disaster monitoring systems, constellation of satellites for disaster monitoring, particularly inclined orbits with synthetic aperture radar, which will give frequent repeativity and will monitor the disaster events. All these are embedded in this particular report that we have. Now it is up to us, I mean ISRO and the operated private sector to accomplish some of these missions and fulfill the needs of the stakeholders and also be providers of data and products to international market as well. I must mention that today, as in the past, most of the users want cooked food in the sense they want ready to use products, models which can be plugged in along with all other relevant data so that you provide a solution to those things. So a large amount of efforts is required in all these efforts. I think stop at this stage by congratulating Nilesh, the President ISRS, and his team for taking initiative in organizing this event. Thank you, everyone.
Thank you, sir, for enlightening us with the various dimensions of remote sensing applications. Indeed, the beauty of a satellite image lies in the application scientist's eyes. As an expression of our gratefulness, we will now have the felicitation of Dr. Naval Gund in virtual mode. May we have the slide, please? Thank you. To get to know, to discover, to publish, and ultimately to utilize the findings for societal benefit. This is the dream of a scientist. Journal of the Indian Society of Remote Sensing is a prestigious and premier Indian journal in the field of remote sensing. On this grand occasion of Silver Jubilee celebration of the IRS-1C mission, a special issue on IRS-1C is being published by the Journal of the Indian Society of Remote Sensing. May we now request our chief guest, Dr. Kasturi Rangan sir, to release the special issue of JISRS on IRS-1C in the presence of all the dignitaries. Sir, please. Thank you, sir, for doing the honors. We are very, very grateful to have with us today Dr. Shailesh Nayak, Director of National Institute of Advanced Studies, former Secretary, Ministry of Earth Sciences, and guest editor of this special issue of the Indian Society of Remote Sensing on IRS-1C. Sir has made outstanding contributions in the vast spectrum of remote sensing applications, and we are very eager to listen to him brief us in details on the special JISRS issue on IRS-1C. Please, sir.
Thank you very much. Dr. Kasturi Rangan, Dr. Shivan, Dr. Nilesh Desai, Dr. Das. First of all, I'm extremely grateful to Nilesh and Dr. Das for inviting me and allowing us to release this special issue on the Journal of Indian Society of Remote Sensing on IRS-1C. I must also thank Dr. George, who was very keen to bring out this issue. And we have been discussing for quite some time what to do, what kind of applications we should have. And we gave this opportunity to Dr. Sandeep Kumar and me. We both are extremely grateful to providing this opportunity. I must also compliment and felicitate all the speakers who were one way or the other involved in providing the leadership for the IRS-1C. And today, I think we have been seeing the use of this, how important it is. The IRS 1C, the special issue which we were planning, we thought, as Dr. Navalgund has rightly pointed out, is a game changer. But game changer from our perspective was also from other angle. We used to go to many user ministries, institutes, but after the launch of IRS-1C, there was visible difference in their reception because it was heralded as one of the best civilian satellite at that particular. And that pride was there everywhere in us also, as well as where we were going. And that helped us quite a bit to accept our data products, our maps, our other services, which is based on the IRS-1C, much more easily accepted. The other important aspect of this is it also provided a combination of the payloads which meets requirement of each and every issue, like agriculture or forestry, water resources, and we tried to see that these applications, which has really reached the operational level, could form part of this journal issue. There are many applications. Actually, we couldn't cover, in a sense, that entire thing. But some of the major application which we could cover was on the agriculture, forestry, water resources, including groundwater and glaciers, geoscience, land use, land cover, urban, coastal, and many, many others. The most important is we are extremely grateful to Dr. Rangan and Dr. V. Jayaraman, who really provided a forward and they brought a real importance and is, as you can see, they also said that the global acclaim was the major issue, the strategy, the governance, how the information is being used for the governance, and we brought the attention to the India. It's extremely well written forward for this journal, and I'm extremely grateful to Dr. Rangan and Dr. Raman to provide this forward to this special issue. I'm also very grateful to all the authors, reviewers, which have done a fantastic job, and my colleague Dr. Sandeep Kumar for extremely managing the entire the entire issue. Thanks are also due to Dr. Prakash and Dr. Agrawal, the executive editor and the managing editor, for supporting this effort. As you can see that the most of this written by the people both from ISRO, SAC and RSC, as well as people who are from the user ministries. So this helped us quite a bit to promote the IRS-1C into the user ministry. Next, there are total 11 articles. These were 5. Can I have the next? Yeah. And we also tried to bring out some of the issues related to the digital mapping, which happened from IRS-1C to the Cartosat, and try to bring out the all major areas which are very much in today an operational level. One important thing which I want to bring it out is that we could reach to this scenario as the world does. One of the reasons which is, in my view, was taken much earlier, almost 10, 12 years ago, about to adopt the CCD technology. I think we did a very wise thing at that time, which also nobody used at that particular time. So this decision to use the CCD technology also helped us to bring world the best at that particular time. I would also like to thank Surida next, who have agreed to free download for next 2 weeks. That means up to February end, anybody can download freely. So this is also and their support for bringing out in a very short time, actually it's only 15 days, this entire issue was ready. So I also grateful to Ms. Suvira of Springer, and my thanks to all the others who have helped from the society and to the Space Application Center, to NRSC, and many other user departments to make this issue worthwhile to keep for a very, very long time. Thank you very much.
Thank you, sir, for briefing the esteemed gathering. A heartfelt thanks for your unparalleled contributions to the special issue of JISRS on IRS-1C. It's now our privilege to felicitate Dr. Nayak. Please accept it on behalf of ISRS via virtual mode, sir. Thank you. IRS-1C, as described by many dignitaries today, was a game changer for space technology and remote sensing applications. The seedling sowed then now covers a vast canopy of inter and multidisciplinary research in India. The satellite images, but also a spectacular illustration of Earth as a dramatic artwork, unrestricted from the visible color palette. The Indian Society of Remote Sensing has prepared a memoir on the journey of IRS-1C from its conception to the accomplished science objectives. May I now request our guest of honor, Dr. Shivan sir, to release IRS-1C memoir in the presence of all the dignitaries. Thank you, sir, for doing the honors. We have with us Dr. R. Mehul Pandya, Space Application Center and Joint Secretary, Indian Society of Remote Sensing, who will brief us on IRS-1C memoir prepared by Team ISRS.
Thank you, Arpita. Good afternoon and namaskar to all the respected dignitaries on this esteemed panel and to all the participants attending this event. I am honored and privileged to brief you all about the IRS-1C memoir. As we all know, that memoir is a document which can take us to a remarkable past experience that many of us did not experience at that point of time. And as per a famous quote, which says, we must study the past perfectly if we wish to define our future properly. We at SAC, with the help of ISRS and other colleagues, have prepared this memoir by collecting distinct and discrete pieces of IRS-1C history at one place. So let us see this colorful memoir. Yeah, so this was the exceptional mission of IRS-1C, which started with the recommendation of this committee with the specific mission objective and requirements for IRS-1C to have 3 unique cameras, PAN, LIS3 and WIFs. With the specifications, as Dr. Naval Gund said, with very higher, radiancy, saturation radiancies. And I just want to just show a historical picture before launch of Dr. Rangan and Dr. George Joseph in front of IRS-1C satellite. After its launch in polar orbit, we had a lot of defined, reference scheme. We had all those data product schemes and data products in picture, and with the help of these, beaming of beautiful pictures, initial images of LIS3, panchromatic data from PAN, and wide field sensor WIFs images. These are some initial images, historical images WIFs we have collected in this particular memoir. And this also gave opportunity of merging the data. Ultimately, it opened up opportunities for newer applications, like as our all esteemed speaker said, for crop assessment, which was the main beneficiary, forestry applications, which helped in many of the flagship applications projects of the national level like CAPE and other projects, land use, land cover mapping. Then we always have, coastal zone management, which one of the very important applications, coral reef and mangrove mapping using IRS-1C, or cadastral mapping, which was first time possible using PAN and list 3 merge for urban planning and GIS applications. So it actually propelled the arena of applications as far as IRS-1C is concerned. And this is some of the beautiful images, which ultimately scientific publications of, all the dignitaries on this particular panel, those all stalwarts have contributed to current science, some 22 papers. And we thank all project management executives, all the team members, technicians, engineers, and all the people who contributed to this exceptional mission, which changed the arena as far as IRS applications are concerned. And we thank Shri Nilesh Desai sir, D.K. Das sir, Dr. George Joseph sir for guiding and making this possible. Thank you very much. I think this memorable memoir will give us a lot of, beautiful memory of that past. Thank you very much.
Thank you very much, Dr. Pandya. Indeed, it was the beginning of new era of remote sensing in India. We are pleased to have with us today the Project Director of IRS-1C, Dr. S. Kalyan Raman. Dr. Kalyan Raman joined ISRO in January 1972 as a communication engineer during the formative years of ISRO. He developed communication systems for satellite platform for Aryabhatta, Bhaskara, Rohini, and Apple satellites, which were successfully flown. He was further given the responsibility as Deputy Project Director for IRS-1A satellite, and later as Project Director IRS-1C, and subsequently as the Program Director IRS projects. May we please request you, sir, to deliver your talk on IRS-1C realization efforts. Sir, please.
Good morning. Our chief guest, Dr. Kastur Rangan, our guest of honor, Dr. Shivan, distinguished scientists from ISRO, ISRS, and ISG, and all participants. At the outset, let me wish you all a very happy New Year 2021, free from coronavirus. I'm very happy to listen to distinguished scientists from ISRO who spoke about all important technical aspects and other aspects of IRS-1C project. I don't have to repeat those. With nostalgia, I look back at those times of IRS-1C project realization. IRS-1C made history at that time as an advanced satellite in civilian domain, offering high-resolution panchromatic imageries along with multispectral medium and low-resolution imageries with wide field of view. We had to meet many challenges to realize the IRS-1C. Some were technological challenges and some were geopolitical in nature. Added to this were the launch campaign challenges with harsh winter weather of Baikonur Cosmodrome at -25 degrees centigrade. All these hurdles were overcome and the launch was successful on this day 25 years back. Aviation Week in 1996 allotted a section for IRS-1C with the cover page caption, "Success on a shoestring budget." IRS-1C was a path-breaking effort and well recognized the world over at that time. We could recover the cost of IRS-1C only projects by sale of data products and by entering into direct data reception contracts with several countries, including USA. All the technologies for IRS-1C satellite were evolved from IRS-1A, for which Dr. Rangan was the project director and I was his deputy. IRS-1C had reflective optics for panchromatic camera, whereas for other cameras, we had refractive optics. It's a happy occasion, the 25 years after IRS-1C launch and Dr. Rangan's 80th birthday year coincide. It is our good fortune that he was born in India and was our chairman at the time of launch of IRS-1C only and beyond. His overall guidance has helped us achieve success. May God bless him with a long active life to continue his journey of serving India in various capacities. I take this opportunity to pay my respectful homage to Professor U.R. Rao, former chairman ISRO, who infused dynamism all around. He got the project approved and provided his expert guidance in the initial years of IRS-1C. My respects to Dr. George Joseph, who is also 80 plus in age, who efficiently guided his team, consisting of Dr. Ramrathan, Dr. Kiran Kumar, Angshan Jaya, and others, in realizing the payload developments at SAC. May God bless him with a long, active life. I am grateful for the guidance and support provided by Sri Aramuya in running the project. He was director of the Lead Center ISAC and the chairman Project Management Council. I am also grateful for the valuable contributions and support given by center directors, unit directors, deputy directors, and group directors, and the ISRO headquarters, Earth Observation System Office for realizing IRS-1C. My special thanks to Dr. Goyal. Dr. Goyal and myself worked very closely, and he has helped me during IRS-1A and IRS-1C. The entire work of IRS-1C consisted of space and ground segment realization, including data products, operating the space and ground segment successfully for more than 9 years, and the application usage of the data. I salute all PMB members, project managers, IRS PMO members, excellent team, all other engineers, scientists who contributed their best to the project. It's a long list which should include support from technicians and administrative staff as well, who have contributed to the success of IRS-1C project. Due to the paucity of time, maybe I can mention some key executives in IRS-1C team. Dr. Amratan, who was APD payload for IRS series, and Sri Rajangam, who was DPD spacecraft, and then he became project director for IRS-1D, which was a sister satellite of IRS-1C. I also want to mention Dr. Majumdar, who was in charge of the data products at SAC. I must mention here the sincere and sustained efforts by Mission Director Dr. Shivakumar, who with his team could run the mission successfully for more than 9 years. I am very sad that he is no more. I acknowledge all their efforts with sincere thanks. As Project Director IRS-1C, I am extremely happy that the data has been put to use very well by various users. Thank you, Dr. Navalgun. Since my superannuation in 2002, I have been observing good progress in remote sensing program. My appreciations and congratulations to all project directors of IRS projects for the excellent performances. Finally, very important, I thank ISRS and ISG for arranging this webinar to mark 25 years after the launch of IRS-1C, which helped us to look at our past. In conclusion, we look forward for an excellent future for remote sensing program of ISRO. Dr. Shivan, President Chairman ISRO, is keeping the ISRO flame up. I wish ISRO Chairman and all ISRO scientists success in all future endeavors. Wish you all a happy New Year 2021. Thank you.
Your valuable experiences. We thank you for wishing us a very happy new year free of coronavirus, and we wish you the same, sir. On behalf of the Indian Society of Remote Sensing, please accept our felicitation in virtual mode.
Thank you.
Thank you. We have with us today another very popular scientist from IRS-1C Project Management Board, Dr. Ram Ratan, Associate Project Director, Payload on IRS-1C. Sir has contributed immensely in ISRO's remote sensing program and paved the way for bright future. He retired as Associate Director SAC and is currently Pro-President at JCRC University in Jaipur. May I request you, sir, to please deliver your talk.
I think he could not join, probably. He was there.
Okay,
He
due
is
to the
not seen
technical
on the panel.
glitches, we are not able to reach to him. Over to you, Samarpita.
As we near the commencement of the first phase of our celebration today, we feel inspired by the presence of the pallbearers of Indian Remote Sensing Program. We want to extend our thankfulness to the entire Project Management Board of IRS-1C, namely S. Kalyan Raman, R. K. Rajangam, Ram Ratan, S. K. Shivakumar, M. S. Prabhu, N. C. Bhatt, T. Kanti Mathinathan, K. N. Suryanarayana Rao, C. Kameshwara Rao, O. P. Sapra, S. G. Raghavan, M. Krishnaswamy, Venkataramu, P. Soma, Anil Kumar, Jairam Hebbar, M. L. Mittal, K. L. Mazumdar, B. V. Sheshadri, Aruldur Vitakan, T. K. Alex, V. Jayaran, K. Tyagarajan, Arvind Kumar, R. N. Tyagi, and all other scientists and professionals who contributed to the IRS-1C program and the follow-up missions in various capacities. We also thank the various user agencies. Today, opportunity to show our gratefulness to two renowned scientists who have contributed immensely to ISRO and are superannuating this month.
It's indeed a fortunate opportunity to celebrate the lifetime contribution of exceptional leaders in remote sensing technology. A successful leader is one who translates vision into reality. We are celebrating lifetime achievement of one such visionary, distinguished scientist and director NRSC, Sri Shantanu Chaudhary, sir. He is a highly accomplished and renowned space scientist and engineer who has made illustrious contributions to the design and development of algorithms for data products generation for a variety of missions, from Earth observations to planetary, wide variety of payloads from optical to microwave, panchromatic to hyperspectral, operational at various sites, NRSC, IMD, and ISSDC. SAR has contributed widely in ISRO's remote sensing program. ISRS family is immensely glad to felicitate you for your exceptional contributions to this organization and our country. May I now request Dr. Vinod Bothale, DD NRSC, to felicitate Sri Shantanu Chaudhary sir on behalf of Indian Society of Remote Sensing on the eve of his superannuation. Sir, for doing the honors. A heartfelt thanks to Shantanu sir for being with us. Today, I personally feel privileged to have got an opportunity to thank you for the mentorship you have provided. Sir, may I request you to please grace this gathering with your words of wisdom.
Thank you, Arpita. I think I am audible. Respected Dr. Kasturi Rangan, Sir, Dr. Sivan, Dr. George Joseph, Dr. Goel, Dr. Navalgun, Sri Kiran Kumar, Dr. Shailesh Nayak, Sri Deepak Das, Sri Nilesh Desai, esteemed colleagues and ISRS members. First, I humbly thank ISRS and SAC for their kind gesture and providing me the opportunity to talk on this occasion. I salute the leaders and the heroes of the successful IRS-1C mission. The remote sensing program has confronted the community with many challenges. And I, along with my team, had the opportunity to resolve few of them. One of the earliest challenge in 90s was to provide the user community with data products with international radiometric quality, and we at SAC contributed in designing radiometric techniques for IRS-1C, 1D, TES, GISOSAT, and CARTOSAT operational missions. Although ISRO had gained enough experience in optical sensors, we faced challenges to operationalize microwave remote sensing missions in the 2010s. Our team at SAC generated quality data products accepted by international community for scatterometer, megatropics, and RESAT payload missions. In order to generate global datasets at near real time for scatterometer, megatropics, and SARAL missions, it was needed to configure a geographically distributed ground segment. Acquiring data in remote ground stations, including Solwart and Bharti, data transfer to Shadnagar or ISSDC stations, processing and disseminating products to national and international weather forecasting stations. We at SAC, ISTRAC, and NRSC contributed to its conceptualization and implementation of such a ground segment. In later part of the decade, the strategic user community had faced the dearth of high-resolution data. ISRO launched a number of CARTOSAT series and DSAT-2B series of satellites. We at ADRENE contributed to reorganize the data centers and provide quality high-resolution data for strategic users and generate DM for all neighboring countries. We are now facing the challenge of transmitting large volume of data from satellites to ground stations. We at NRSC have established Ka-band ground stations for polar orbiting satellites and Ku-band ground stations for geosynchronous satellites at Shadnagar, strategic user stations, and at Antarctica. NRSC has carried out aerial survey and delivered DEM, DTM with 50 centimeter posting and 30 centimeter vertical accuracy over the entire Indian coast for INCOIS for tsunami modeling, for floodplains of Brahmaputra, Godavari, and Tapi for flood early warning models. And our instrumented mobile station currently has mapped 2.5 centimeter posting, 5 millimeter vertical accuracy surface models for Chitradurga artificial craters for lunar simulation. In keeping with NNRMS traditions, we have generated land use, land cover, land degradation, and wasteland maps, water body and runoff data, forest loss and forest fire alerts, for flood inundation maps in near real time, urban geodatabases for more than 300 en-route towns, in finer and finer scales, and improved temporal frequencies. The country is still passing through an asset recording phase, and Bhuvan portal with high-resolution data and thematic layers in the background is supporting geospatial activities of more than 100 applications, including GeoManreka, IWMP, NHRR, and SMARAC, etc. It is time now to proceed from mapping to modeling. Young scientists at NRSC have developed flood early warning models, water balance models, crop simulation models, pollution transport models, etc., in addition to development of new remote sensing applications. for mineral prospecting for rock phosphate and diamond, smart sampling for crop incidences, carbon sequestration estimates for the entire forest land, physical and biochemical studies of coastal, riverine, and ocean processes, permafrost studies. At Arctic, we have established flux towers, network of lighting detection systems, network of core stations for recording tectonic activities, resistivity measurements for subsurface tomogram for groundwater and host rock, all to fuel analysis, research, and validation. I thank my mentors, D.S. Kamath sir, Dr. George Joseph, Dr. A.K.S. Gopalan, Dr. Naval Gun, Shri Kiran Kumar ji, Dr. K.S. Dasgupta, Shri A.R. Dasgupta, Dr. K.L. Majumdar, to enable me and my team to realize interesting components of ISRO's mandate. Thank you. Thank you very much.
Thank you very much, sir, for your words of wisdom and encouragement. Thank you very much, sir, for your words of wisdom and encouragement. It is said that a good leader leads the people from above them, but a great leader leads the people from within them. Space Application Center has achieved new levels of glory and success under the able leadership of distinguished scientist and director Shri D.K. Das sir. Sir has played an instrumental role in the building of the constellation of Navik, in conceiving the development of high-throughput satellites, including GSAT-11 and GSAT-19. His contribution in communication and navigation satellite technology is unparalleled. Sir, we take this opportunity to felicitate you and congratulate you for your long and successful career. You are an inspiration to all of us, and your dedication to work is exemplary. We would kindly request Dr. George Joseph to felicitate Sri D.K. Das sir, Director SAC, on the eve of his superannuation. Sirs, please.
The day he joined the Space Application Center.
Thank you, Das sir. Thank you, Dr. George Joseph, Dr. Rajkumar, Sri Nilesh Desai sir, Rajiv Jyoti sir. Directors, please share a few words with this august gathering.
Respected Rangan sir, Sivan sir, Kiran sir, Goel sir, George Joseph sir, Navalgun sir, Shailas Nayak sir, Kalyan Raman sir, Ram Ratan sir, Santanu Chaudhary ji, Nilesh ji, Rajkumar ji, my all senior colleagues, gurus, friends, and ladies and gentlemen. I am extremely thankful to ISRS for the honor that I have received at the end of my journey with ISRO. I completed on 12 December 73 years. Sorry, 37 years. Of these 37 years, most of the time I spent with communication and navigation payload development. I could get opportunity to work for remote sensing only for last 4 years. And during that time, I was lucky to get associated with RISAT, NISAR, ResearchSat, CartoSat, GISAT, HISIS, Chandrayaan, etc. Also, some very interesting and important application program I got associated with. Now I am here for another 3 days. Now while bidding you adios, I would like to quote few lines of Robert Frost. The woods are lovely, dark and deep, but I have promised to keep
and miles to go before I sleep, and miles to go before I sleep. Thank you.
Thank you, Das sir, for your kind words. It's an opportune moment for all of us to hear from you, sir. We are thankful to have with us today Director URSC, Sir. Sir, we are humbled by your presence. Please accept our greetings. Executing a program of this magnitude requires hard work of many. A word of thanks to appreciate and acknowledge the efforts goes a long way in encouraging and keeping the spirits high. May I now request Dr. Hitendra Padalia, Secretary ISRS, to offer a formal vote of thanks. Dr. Padalia, please.
Respected chief guest of honors of today's program, dignitaries, all the viewers, ladies and gentlemen, a very good evening to you all. On the behalf of Indian Society of Remote Sensing, it's my privilege to propose the formal vote of thanks at the end of Silver Jubilee function of IRS-1C. At the outset, we express our deep sense of gratitude to the chief guest, Dr. K. Kasturirangan, former chairman ISRO and architect of new education policy of India, for his gracious presence and enlightening us about the critical role played by each of his team member, which led to building one of the world's best civilian satellite in the form of IRS-1C for successful operational use. Thank you very much, sir. Our heartfelt thanks to guest of honor, Dr. K. Shivan, Secretary, Department of Space and Chairman ISRO, for sparing his precious time and unveiling the ISRO's remote sensing vision for meeting national imperative through advanced satellite system and commercial opportunities for private players by unlocking the space sectors. We are very much obliged to you, sir. We are indebted to the chief architect of IRS-1C sensors, Dr. George Joseph, former director SEC, for giving us a leading space engineer perspective on innovation performed in developing camera system for IRS program, key future messages, and also for mooting the idea for celebrating IRS-1C Silver Jubilee. Thank you, sir. We extend our sincere gratitude to Sri A.S. Kiran Kumar, former chairman ISRO, for accepting our invitation and also taking us through the incredible journey of development of three-tier imaging system for IRS sensors. We are grateful to Dr. P.S. Goyal, former secretary MOES, for his inspiring talk, how IRS-1C mission as a major technological feat was realized at that time, and how it offered a global leadership to the country. Thank you, sir. Our earnest thanks to Dr. R.R. Navalgund, former director SEC, for giving us an excellent narrative on value addition achieved through IRS-1C mission in different thematic areas, and also for sharing very interesting anecdotes. We would like to sincerely thank Dr. Shailesh Nayak, Director, National Institute for Advanced Studies and former Secretary MOES, for sharing his remembrance of IRS-1C and for bringing out a special issue of JISRS on IRS-1C along with co-editor Dr. A. Senthil Kumar and JISRS editorial team. We being in application area get very rare occasion to meet our leading technologists of the past space missions. We are obliged that we could hear reminiscences of IRS-1C from none other than Dr. S. Kalyan Raman, Project Director, and Dr. Ram Ratan. He was not could not join the program, APD of the mission. Thank you, sir. Every one of you with your august presence, sharing your fond memories of IRS-1C and offering invaluable guidance to meet emerging application need has made today's program a cherished experience for the participants. ISRS takes immense pride in felicitating the leaders and the project executives for their significant contribution in IRS-1C mission. It is also a matter of great honor for ISRS to felicitate Sri Santanu Chaudhary, Director NRC, and Sri D.K. Das, Director SEC, for their lifetime contribution to the cause of promotion of space technology for the benefit of the country. We are grateful to Dr. George Joseph Sir, Sri Uma Maheshwaran, Scientific Secretary ISRO, Dr. Santanu Badwatikar, Dr. Vinod Bothale Sir, for felicitating the dignitaries, and also thank EPDO ISRO headquarter team for their help. We are thankful to Sri Nilesh Desai, President ISRS, for conceptualizing Silver Jubilee of IRS-1C, providing overall guidance, and ensuring a very special appearance of leading contributor of IRS-1C mission in today's event. Thanks a lot, sir. Executive Council of ISRS is thanked for their guidance. We greatly acknowledge the dedicated contribution of SEC team, Dr. Raj Kumar, Sri Rajiv Jyoti, Dr. Rashmi Sharma, Dr. Mehul Pandya, Dr. Ram Rajak, Dr. CP Singh, and other team members, and ISRS Ahmedabad chapter in organization of these events. We thank Dr. Mehul Pandya, Joint Secretary ISRS, and his team for preparing a beautiful memoir of IRS-1C. We also thank DECO team for preparing a beautiful video of IRS-1C and for their technical support. Special thanks to Active Science Tech Communication Private Limited for their services. We plan to digitally archive all the messages delivered today to cherish the legacy of IRS-1C. In the end, a big thank you to all those who have joined us live to celebrate the Silver Jubilee of IRS-1C. Wish you all a very happy New Year. Thank you.
Thank you, Dr. Padalia. I would like to mention one name here, which by mistake we have forgotten, Dr. Virendra Kumar, Director DECO. We are grateful to you, sir, for being with us and extending support to carry out this program smoothly. Thank you, sir. Please accept our greetings.
As we take another step forward towards the vision of Dr. Vikram Sarabhai, the father of India's space program, of being second to none in the application of advanced technologies to the real problems of the man and society, we are more resolute than ever before to achieve the same. We will now have national anthem, after which we will have a group web photograph of all the dignitaries present with us today. We request all to switch on the web cameras as well.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Let's capture today's memories to treasure for a lifetime.
प्रताप जी हो गया सबका फोटोग्राफ? प्रताप?
प्रताप?
Yes, हो गया.
Thank you very much all for joining this historical event. Thank you. Have a great day ahead, great year ahead. Thank you.